there is a lot of terminology surrounding AI. Instead of assuming you already know what I mean, in this lecture I invite you to briefly go over some of the most important terms that we will be using throughout the course, just to make sure that we are on the same page. And we're going to begin with AI. It is even in OpenAI. AI stands for artificial intelligence and is essentially the simulation of human intelligence by computers. AI enables computers to think like humans and learn new things, solve problems, make decisions, and even create something new which never existed before. AI is a generic term that includes a range of techniques for enabling computers to perform intelligent tasks. The next concept I want to talk about is machine learning. Artificial intelligence and machine learning are related but still different concepts. Machine learning is considered a subset of AI and refers to the development of algorithms that can learn from a provided dataset without being explicitly programmed. Some machine learning algorithms are modeled around the structure and function of the human brain and are called neural networks. This type of algorithms essentially simulate how the human brain works. In this context, we may also encounter the term deep learning, which is part of machine learning. In conclusion, we can say that machine learning is a technique for achieving artificial intelligence. Let's next talk about machine learning models. A machine learning model, or simply model, is the result of training a machine learning algorithm on a particular dataset. Here is an example to help illustrate this concept. Let's say we want to create a model that can recognize whether an image contains a cat or a dog. First, we need a large dataset of images of cats and dogs. Apart from this, each image needs to have a label indicating if this is a cat or a dog. This is our training dataset. Next, we need to develop a machine learning algorithm which aims to identify some patterns. For example, the shape of the head, the texture of the fur, the eyes, and so on. Initially, our model is dumb. Training is like going to school and learning. The model is learning based on the way the algorithm has been created. The output of this training is a model. This is what the algorithm has learned from the training data. If you provide a new and unseen image, the model should now be able to tell if the image provided is a cat or a dog. So to recap, we develop a machine learning algorithm which can create a machine learning model which we can then use on new data. When dealing with OpenAI, we work with models that are the result of training with a particular machine learning algorithm developed by OpenAI. Let's talk about prompt for a second. A prompt is the input we give to a machine learning model to generate output. In the context of ChatGPT, what you type in that text box is considered a prompt. How we write the prompt plays a critical role in the quality of the response we get from the model. A prompt helps to guide the generation process by providing style, tone, and content. If we tell the model to generate funny responses, this will be part of the prompt. So how we design our prompts plays a key role in how we use a model. Next, we're going to talk about tokens. To process text, a model needs to split it in small chunks it can digest. We call this small chunk of information a token. You can think of a token as a word in a sentence. However, this is not 100% accurate. Special characters like punctuation marks can also be considered tokens. Some words are also broken down into tokens. Let me show you an example. This is the tokenizer from OpenAI, which can help us get an idea of what exactly is a token. So I'm going to go ahead and copy, for example, a text that's already appearing here. I'm going to paste it here in this box. What you will see here below is actually the breakdown of this text in tokens. So almost every word is a token, but there are still some words that need to be broken down into multiple tokens. Acronyms, compound words, and words that have prefixes or suffixes are some examples of words that are broken down into multiple tokens. Now, we don't need to concern ourselves with how this happens exactly. Just having a general idea about this concept is sufficient. In this case, we'll see the is a token, but GPT has been broken down into two tokens. So essentially, every different color represents a token. A comma here is its own token. A dot is its own token, and so on. Essentially, if we're looking at this from a bigger picture, we can say that 100 tokens represent 75 words. We need to know about tokens in the context of working with different models and pricing. The more tokens we use, the higher the cost incurred. The models we'll be using can only process a limited number of tokens. Also, the output generated is limited. I hope this brief introduction to these technical terms was beneficial. Bear in mind that the explanations provided are extremely simplified, as the technology behind AI is quite complex. In this lesson, we will learn how to install Postman. Postman uses a freemium pricing model, and for many use cases, including this course, it is free to use. There are two ways of running Postman. In your browser, it's called Postman on the web, or if you download a standalone app that you install on your computer. There is also an old and deprecated Google Chrome extension. Don't use that one, as you will not be able to follow along with the course. I will be using the standalone app throughout this tutorial, but the browser functionality is very similar. You will find detailed installation instructions in the course notes. The first step you need to take is to go to postman.com and create an account. I highly recommend creating a Postman account, as this will make your life easier. The setup after this is relatively easy. There are just a couple of details you need to enter before you can use Postman, and at this stage I will not create a team. To use Postman, simply go to Workspaces and select My Workspace. If you wish to use the browser, this is all you need. If you wish to install Postman, you will find an installation kit for Windows, macOS, and Linux. So if you wish to use the Postman app, the next step is simply downloading the app and installing it. When you open the app for the first time, it will look pretty similar to this one. And in order to connect the app with your account, you will have to click here on the Sign In button. Next step, we'll go to Workspaces and select My Workspace. This is essentially where we will organize the work. Postman is actively developed. By the time I finish recording, editing, and publishing this course, a new version will be released. You may notice slight differences from what you see right now in this video. However, I can assure you that the principles stay the same. I will update the videos or the course notes if there's something really important you need to know. The first thing I like to do is switch to a dark theme, which you can do from Settings. The settings are located here. And from the themes, I will select the dark theme. To use the ChatGPT and OpenAI APIs, you need an account with OpenAI. If you have been using ChatGPT, you already have an account. If you are not sure, go to platform.openai.com and try to log in. If you don't have an account, go ahead and create one by clicking on Sign Up. It is important that you complete all the steps I'm going to mention to ensure that you can work with the API. You will need to provide an email address and a password. After this, check your email for a link that confirms your email address. Next, you will need to provide a few details about yourself and agree with the terms of OpenAI. You also need a valid phone number where you can receive a verification text message. Finally, probably for statistical purposes, you will need to say how you plan to use OpenAI. And this is it. you should see this page, which is the starting point for working with the OpenAI API. This is also the page you will be seeing every time you sign in. Begin by creating an API key, which is needed to use the ChatGPT API. Next, we'll make a simple request against the API to get a list of all available OpenAI models. And last but not least, we will build a request against the ChatGPT API. The first thing we need to do is to go to the address platform.openai.com and log in with your account. After you have logged in, you should see a page that is very similar to this one. And here on the top corner, you will see your name initial and you'll see personal. If you click on this one, you can go here to view API keys. And this is where we can generate the API key, which we will need to access the API. Initially, you don't have any API keys, so simply go ahead and click on Create New Secret Key and keep this window open for a while. You may need this in case you're losing the API key. So I'm going to go ahead and copy this. Now that we have an API key, let's go back to Postman and store it. In order to store this API key, we're going to go ahead and create a new collection. And I'm going to call this collection OpenAI. From the collection, I will see here the option variables. I'm going to close this panel here. Let's go ahead and create a variable which we can call API key. The initial value doesn't really matter, so I'm going to write something like fix me. And in the current value, I'm going to paste the API key which I've copied from platform.openai.com. Let's go ahead and save this. The next step would be to test if our API key is working correctly by sending out a very simple request against the OpenAI API. I am here at the OpenAI official API documentation, and we'll see here on the left-hand side API reference. This is the part that is describing how the API is supposed to work. And this is something that we're going to use throughout the course because the most updated information is always available here. Of course, this documentation is something that changes a lot, so what you will see when you're watching the course can be slightly different from what I'm showing in the video. So this is why it's important to understand from where I'm getting this information, so that in case something changes, you can put one and one together and figure things on your own. Let's go ahead and get a very simple request to work. And the API has an endpoint, which is the model's endpoint. And this endpoint is very, very simple to call and gives information about all available AI models that OpenAI offers. So what I'm going to do here, I'm going to copy this address. I'm going to go back to Postman and open up a new tab. This is a GET request as it says in the API documentation, so there's nothing we need to change about the HTTP request verb. And I'm going to paste this. We'll see in this case, I've introduced here an unwanted character. Whenever we are copy-pasting data, we want to make sure that we are not introducing new lines, spaces, or any other characters that we don't want. So I'm going to go ahead and remove this from here. And now it looks much better. Let's go ahead and send this. And what we'll see here is a very typical error. It's 41 unauthorized. And here in the response body, we're getting a detailed message about what's going on. Essentially, this endpoint requires authorization, which we can provide through the API key. Now, currently, we haven't done this for the request, so this is why it is not working. It's absolutely expected. What we will do next is to save this request in the OpenAI collection by clicking on the Save button. I'm going to name the request Get Models. And I'm going to select the collection OpenAI. Just in case you don't initially see it, make sure that you have saved the collection. And additionally, close this again and click again on Save. It's probably a glitch if you cannot see it. So it's important that we're saving this request inside the OpenAI collection. The fact that we have saved this request inside the collection doesn't mean that this authentication problem is solved, but we can solve this at a collection level because all the requests that we'll be using actually require authentication. So I'm going to go to the collection, and just in case you've closed this tab, you can simply hover over the collection name until this ellipsis shows up. Click on it, this context menu will open up. You will see here Edit. So this will give you access to the variable that we have defined. But additionally, what we want to configure here is actually this authorization. So here, if we click on authorization, currently there's no authorization defined. But we want to select one from the list, and that is bearer token. This is what OpenAI expects from us. So the token is actually stored in a Postman variable. So I'm going to type here 2 braces. And this autocomplete will kick in, and you should see the name of the variable as you have defined it. In my case, is API key. And even if you hover over it, you'll see here the current value, which should be the same as the API key, which you have copied from OpenAI. All right, let's go ahead again and click on save. Go back to the get models request and hit that send button once again. And what we're actually seeing here is a status 200 OK. And we're going to see here in the response a bunch of models and a bunch of data that we're getting back. This response is formatted as JSON, which is a format used when we are transferring data when using APIs. The model that is being used by ChatGPT is actually called GPT 3.5. So if we go ahead and search in this response for GPT, what we will see here is one of the models available, but this is kind of like a temporary version, so this may go away. It's not considered something stable. We may use it, but it's not the most stable one. So if you search for the next occurrence, we're going to see this one. GPT-3.5-Turbo. So this is the model that we actually want to use. It's always a good idea to use this endpoint to check if the model that you want to use is actually available through the API. And if it's available here, then you know that you can use it. Welcome to this section where we'll go a bit deeper into the models offered by OpenAI through the API. The goal of this section is to give you an overview of the most popular models and show you a brief example. OpenAI provides a series of models, each trained to have a specific capability. For example, the ChatGPT application uses a model which is called GPT 3.5 Turbo. This model can be used for chat, but also for many other tasks. GPT 3.5 Turbo is also the most advanced language model from OpenAI. GPT 3.5 refers to a set of models which can understand and generate natural language or code. While there are also other models in this set, GPT 3.5 Turbo is the most advanced one. So, as long as we work with text or code, using one of these models makes sense. This is where we'll be spending most of our time. However, not all models generate text. For example, DALL-E is a model that can generate images based on a given prompt that provides a description. Whisper is a text-to-speech model that can take as an input an audio file and transcribe it. Some models are built only for generating code, such as the models listed under Codex. For example, GitHub Copilot is powered by Codex. There's also a series of GPT-3 models, which are not to be confused with the latest generation, GPT 3.5. GPT-3 models are an earlier generation of models that can understand and generate natural language, but are currently obsolete. Their training data is also much older, so we won't be paying a lot of attention to them. So in a nutshell, this is what we'll be covering in this section. Generally speaking, models that can understand and generate text can be used for virtually any task. However, if we were to make a general classification, the following categories of tasks would come to mind: chat completions, general text completions, and code completions. Let's talk about the word completions for a second. In this context, a completion refers to generating new text that is similar to the text which was used to train the AI. Let's say that we provide the following prompt. Write a title for a blog article explaining how to use the ChatGPT API. In this case, the completion can be something like this: unlocking the power of ChatGPT, a step-by-step guide to using the ChatGPT API. This is called a completion because the model uses probabilities to predict which word is likely to follow the one before it. So this is why text generated by these AI models is so human-like. Let me give you some other examples of completions. asking the model to brainstorm ideas for what you can cook with a list of ingredients, providing factual responses, translating text, or providing a summary of a larger text, and many other use cases. So completion is a more general term of tasks that a model can perform, while, for example, a chat completion is a more specific task. It's about interacting with a model in a conversational way. If we ask a model to generate programming code, this is also a completion. It is called a code completion. I hope that now you have a better understanding of the concept of completions when dealing with these AI models. In this lecture, I wanted to show you an important tool when working with OpenAI models. This is the OpenAI Playground. You will find a link in the resources folder that takes you to this page. The OpenAI Playground is essentially an intermediary step to using the OpenAI API. It allows us to get familiar with the different models available and play with them in an easy way. So let me give you a brief overview of the interface that you see here. First of all, there are different kinds of modes. There's the complete mode, there's the chat mode, there's also an insert and edit mode. We'll be mostly working with the complete and chat mode. When you select one of these modes, you have available a list of models that you can use. For example, if you want to use the model that ChatGPT uses, we'll have to select the chat mode, and we'll see that the model selected is GPT 3.5 Turbo. Apart from this, there are also here some settings that we can control, and for some of these modes, there are also given examples. For example, if I select complete mode, we'll find here a preset, and here are different examples of how these models are used. In this section, we'll be working with the OpenAI Playground, and I just wanted to briefly introduce you this tool. GPT 3.5 is the term used to refer to the latest generation of models designed to work with natural language or programming code. ChatGPT uses the GPT 3.5 Turbo model, which is the most advanced language model. When working with the API, don't get distracted by the fact that this model is available under chat completions. You don't need to build a chatbot. With this model, you can write a response to an email based on a discussion thread, write JavaScript code, translate text from one language to the other, make a summary of a longer text, or fix grammar or spelling mistakes in a text. And of course, you can create chatbots, but many other things. This chat model receives a sequence of messages as input and produces a new message as its output. Let me show you what I mean by opening the OpenAI Playground. Here inside the Playground, the first thing that we will do is to select the mode. So the mode that we are interested in order to use this GPT 3.5 Turbo model is to select here Chat. And we'll see here which are the models available. When working this particular model, the API gives a bit more structure compared to other models. The messages that we're sending are essentially attributed to three different roles. There is a system role, there is a user role, and what comes back from the AI assistant is the assistant role. The system role is only used once to set a context and configure the behavior of the assistant. A very general way to configure this is just by saying you are a helpful assistant. Next, we have a message with a user role, and here is a content. For example, how many states does USA have? Let's go ahead and submit this. And what comes back from the AI model is a message attributed to the role assistant, and it says the United States of America has 50 states. So these are the messages. This is one message with the system. This is the second message with what the user is asking. This is the third message that comes back from the AI model. While these messages are not necessarily mandatory, this structure is very useful when working with this particular model. Let's go ahead and take a look at how we can configure this model to translate text, for example. You can specify something like, you're a helpful assistant that translates English to German. So let's go ahead and delete this previous message that we have. And we're going to change this current one. For example, let's translate this text. Where is the train station? Let's go ahead and click on submit. And we're going to get the version in German. Wo ist der Bahnhof? This is how we now have used this system message to essentially change the behavior of this model. If, for example, we were to remove something, so for example, we are leaving this translation part aside, let's go ahead and remove this message. I'm going to click here on submit. We're going to get something else back. So this is why the system message is very important for giving that context, for giving that initial instruction to the model to understand what are we trying to do essentially. Let's go back to Postman and try to implement this exact example. I'm going to go back to the OpenAI collection and open the existing chat completion. We are here inside the body, and these are the messages that we're sending. So we can see here we have this messages array. We currently have only one message. Each message has two properties, role and content. Let's begin first with the system message. So I'm going to go ahead and copy this structure that we already have. Add here a comma to make this valid JSON. And we're going to change here the role from user to system. So let's say you want to implement the example where we are translating. So the content of the message will be, you're a helpful assistant and you're translating from English to German. We can jump back to the playground, copy the message that we had there, and simply paste it here. Now, next with the user role, this is essentially what the user is asking. This is what we want the AI to do. So let's go ahead and change hello and replace it with this message that we have here, which is asking where is the train station. So what we expect this to do is, as in the playground, to translate this into German. Let's go ahead and send it. And we're going to take a look at the response. And what we're going to see here is a message. Role is assistant. So this is coming back from the assistant. And it's telling us this is a translation in German of what we have provided in English. Of course, if we want to build a conversational bot, we need to supply the entire conversation history. So for example, if we're asking here a few questions and the context is necessary for the model to provide the next message, also need to provide here as an existing message what the model has answered earlier. For this case, we don't need this, but for a conversational bot, that would definitely be very important, because without supplying the conversation history, the model has no recollection of past interactions. So the model, we can say in some regards, is stateless, doesn't know what we have asked previously. Now, this was just a simple example to get started with this and to understand how we can configure these messages, but we're going to explore this model in a dedicated section. In this lecture, we'll be using the Text DaVinci 003 model, which is also part of the GPT 3.5 generation of models. Let's first interact with this model through the OpenAI playground. In the playground, make sure that the mode is complete. And additionally, from the list of models, select Text DaVinci 003. What we see here, this big window, this is essentially the prompt. We provide any input that we need through the prompt. So this model has a very simple interface. Let's go ahead and write the first prompt. Let's say that we are writing a blog article about the ChatGPT API, and we are looking for a good title. We can write a prompt which is something like, write a title for a blog article explaining how to use the ChatGPT API. Let's click on submit. And what we'll see here in green is the response from the model. If we don't delete the response from the model and click on submit once again, we're going to get this error here. So essentially it's telling us there's nothing else that the model can do right now. So if we want to run this again to get maybe a different idea for a blog title, I have to remove that and click here once again on submit. Text completions can also be used for transforming text using, for example, translations. Let's say, for example, we want to translate a text in German. So we can say, translate the following text in German. So let's say the text one I want to translate is, I've missed a train because I couldn't find the train station. And let's click on submit to see the translation. So this is a translation in German. Another form of translation is to ask the model to provide a summary of a longer text. So for example, we can write a prompt which says something like, summarize the main idea from this text and explain it in simple terms. I'm going to go to Wikipedia and grab here a chunk of text from an article about OpenAI. And I'm going to go ahead and paste it here. Let's click on submit. And what we'll see here in green is essentially the summary that we have requested, which is a transformation of this original text that we have provided. But we can also use text completions for generating new ideas. Let's say, for example, we're looking for a present. So how about a prompt like, brainstorm some ideas for Christmas gifts for my friend who likes Star Wars. So let's click on submit and see what are the ideas that we have for gifts. And even if this model is not explicitly designed for conversations, we can even use it for conversations. So for example, we can provide some context and tell the AI, you're a friendly and funny AI assistant named Mike. And then what we can do is start essentially a conversation. So we can write here me, for example. I'm going to write a message like, hello, how are you? I'm going to write here AI column. I'm going to go ahead and click on submit. And then what we're getting back is, hi there, I'm doing great. How can I help you, right? So then I'm going to write again me. How many states are in the USA? As a question. So the conversation continues. Now let's go into Postman and try and figure out how we can submit a request through the API to the Text DaVinci 003 model. The first thing that we need to do is to go to the API documentation. And this model is available for looking here in the API reference under the completions endpoint. So to use the completions endpoint, we need to submit a post request against this endpoint. So let's go ahead, copy this address. And what we'll do is go to Postman and create this request from scratch. I'm going to open up a new tab, select post so that we don't forget, and paste this address here. Let's go ahead and save this inside the collection so that we have access to the API token. I'm going to name this request text completion, and after that, I'm going to also specify the name of the model. Let's go ahead and click on save. So if we're submitting this request as it is right now, we're going to get back an error telling us we haven't specified the model parameter. So obviously this is something that we need to do. So I'm going to go here to body, I'm going to select raw, and instead of text, we have to select JSON because we are sending JSON. I'm going to start here a new object, and between double quotes, I'm going to write model. And then the model that we want to use is Text DaVinci 003. If you're unsure if this model is available, go to Get Models, run this request, search here for Text DaVinci. There are multiple versions, but the one that we are interested in is this one. I'm going to go ahead and copy the name and take it here in the request. Let's go ahead and send this again. What we're going to get back here is already a completion, even though we have provided no input. So this is just some random thing that's coming back. It doesn't really matter so much. But actually what we want to do is to provide a prompt, right? We want to provide some instructions. So if we go to the API documentation, we're going to see here that the model is required, but the prompt itself is not. So this is a bit surprising, but this is the way this endpoint works. So let's go ahead and copy the name prompt and provide this as a prompt. So I'm going to add here a comma, and between double quotes, I'm going to write prompt. And let's say we're going to start with a very simple prompt. I'm going to use the example with write a title for a blog article explaining how to use ChatGPT API. So this is the prompt that I provided here. Let's go ahead and click on send. And we're going to see here inside choices, this is essentially the response that we're interested in. And the suggestion is a step-by-step guide to using the ChatGPT. Okay, maybe not so good. Let's try it once again. And we're going to get here a different version that we can use. So this already looks much, much better. So under the GPT 3.5 models, we have GPT 3.5 Turbo, and we also have TextAvinci 003. Now the question is, why use TextAvinci 003 over GPT 3.5 Turbo? If GPT 3.5 Turbo is so great, why use something else? Well, actually, for most cases, using GPT 3.5 Turbo is a good place to start. Currently, it is also 10 times cheaper than TextAvinci 003. However, there is no best for all use cases, and it is important to try out the different completion models to see which one provides better results for the kind of use cases that you have. TextAvinci 003 is optimized for traditional completions and not necessarily for chat usage. Apart from this, TextAvinci 003 is a model that can be customized based on specific needs through a process which is called fine-tuning. Essentially, you're providing additional data to the model and you're kind of like continuing the training. This is something that currently in the GPT 3.5 Turbo model is not possible. Apart from this, there's also the aspect of speed. Some responses generated by GPT 3.5 Turbo may take longer. I had instances where it took the API even 10 or 12 seconds to generate a response. While the response generated was great, this long waiting time may be an issue for some use cases. So this is why it's not about which model is best, but it's more about which model is best for you and what you're trying to build. DALL-E is an AI model that can generate images based on a text prompt. You won't find the DALL-E model in the OpenAI playground. If you want to play with DALL-E outside of an API, you need to go to labs.openai.com to get to the labs interface. I've included a link in the resources folder. So these are some examples of images that have been generated with DALL-E. And I must say, I'm quite impressed about their quality, but obviously the prompts are very important. But let's see if we can generate something decent. So this is where our prompt is for this model. And let's say, because we're using Postman, let's try to get an impressionist oil painting of a postman carrying a letter. And let's go ahead and generate this image. And it will take a bit for this to generate. So we'll have to wait for a few seconds. So these are already 4 images that have been generated based on our prompt. And I would say at least one of them looks pretty decent. If I didn't know that this is AI generated, I would have thought that this was actually something someone has painted. Okay, enough playing with this. Let's use the API to generate this image. The DALL-E model is available through the Images API. So if we scroll here down to the API reference, we'll find here images. And in order to actually create an image, we'll have to use a post request against this endpoint. So I'm going to go ahead and copy this endpoint directly and jump into Postman. Let's open up a new tab. So we're going to select here post, and this is the URL that we have. Let's also go ahead and save this. I'm going to call this images-DALL-E. All right, so let's go ahead and send this to see what are the required information. So currently we haven't submitted here JSON object, so let's go ahead and do that. I'm going to select here body, raw, and select JSON. That's the first step. Let's also create an empty object and send that over. So prompt is obviously a required property. In this case, we don't need to specify here a particular model because this is probably automatically selected to this model that is generating the images. So let's provide here a prompt. I'm going to give here the prompt that I've used earlier, which is to generate an impressionist oil painting of a postman carrying a letter. And let's go ahead and submit this. So what we're going to get back is the response. And you will find here the link to this image. So in order to actually see the image, we'll have to click on it. In Postman, this will open up a new tab. We'll have to click here on Send. So we're essentially just fetching this image that is here. And this is the image that has been generated. Jumping back at the API documentation, we can even see here what is part of the request body. So obviously the prompt is required. There are also a few things that we may want to do. For example, in one request, we can generate multiple images by specifying the N parameter. And just as well, we can also specify here the size of the images. Maybe initially we want only smaller images, don't want to wait so long for larger images to be generated. So it may make sense to have a smaller image. So let's add this to our request. I'm going to close this tab because we don't need this anymore. And here from the body, I'm going to add here a new property. So comma, this is N, so it indicates how many images we want to get. Let's say we want 4 images. And the next property from the API documentation is size. And we need to specify here the size as a string. So let's take just the smallest image. I'm going to paste it here. Okay, so now we should get back 4 images from this API. Let's see how it works. Now we'll see here in the response body under data, we have an array and we are getting 4 images back. So let's click on one of them, submit this request, and we'll see here the image is much smaller. So this is one of the images, the second one, yeah, and so on. So essentially, this is a very nice API for quickly generating some images based on a prompt. The interface is quite easy, and I would say the results are quite impressive. Whisper is an AI model that can turn audio to text, and after the first experiments, I must say that I'm quite impressed by its capabilities. Currently, this model is not available through the Playground or any other web interface, so what we'll need to do is to directly use the API. So let's jump here into the API documentation, and this will be part of the audio. I'm going to click here on audio. And what we'll see here is the endpoint that allows us to create a transcription. So let's go ahead and copy this endpoint. And again, please note that this is a post request. I'm going to open up a new tab and also select here post after pasting the URL. Let's go ahead and save it in the OpenAI collection. And I'm going to call this audio transcription Whisper API. Let's take a look again at the API documentation and see what is required and what is not. So first of all, we need to specify the model, and we also need to specify a file that we want to transcribe. So let's begin with the model. Currently, it says that only this Whisper 1 model is available, but we should do an effort to see if this model is actually available through the API. So I'm going to simply go ahead and copy this, open the get models endpoint, and send this request. Let's go ahead and search for this model, and we'll find it here, Whisper 1. Okay, so this is the name of the model, which means we are on the right track. So what we need to do is go here inside body, and this time we're not going to send this as JSON because we need to upload a file. So what we need to do actually is to select form data, and here we're going to write one key, which is the model. And I'm going to paste the value Whisper1, which I got from the get models endpoint. And the next required key that we need to provide is file. So if we see here again, the API documentation, we have file and model, both are required. You can also provide a prompt, but this is optional, so we're not going to do it initially. So let's go ahead and provide here file. So how do we upload this file here in Postman? Well, this is not so super intuitive. So I want you to pay a bit of attention. As I'm hovering over file here, you would see here text appearing. Actually, when you click on text, this drop-down opens up. You will see here two options, text and file. So text is by default, and file is what allows us to actually upload the file. So once again, normally you don't see anything here if you don't hover over it. But once you put your mouse over this, you will see here text. So let's go ahead and select file. And now we have this select files open. So what I'm going to do is going to click on select file and select the file that I want to transcribe. To make your life easier, if you don't have an audio file, I've already included an audio file in the resources to this lecture, so you can simply download that and use it in this example. So this is how it looks like with this file selected. So model and file, we have both required properties that we need to send to this endpoint. So let's go ahead and click on send and see what is happening. And actually what we're getting back, super simple, is the transcription of the audio file that we have provided here. What you need to keep in mind is that the maximum size here is 25 megabytes of data that you can send at once. So it's of course ideal to work with audio files in this case, not with a video file or something like that, which is much larger. And also when you're working with files, so compress the files to make them as small as possible if you have, for example, something longer that you want to put into text. So in a nutshell, this is how we can work with the Whisper API to take an audio file and get the text out of it. The quality of the output we get from a model is directly proportional to the quality of the prompt. Because the models are very powerful and can do many things, we need to be very explicit in describing the desired output. If our prompt is short and unspecific, so will be the result. I'm here inside OpenAI Playground, and I have selected here the chat mode, and I have the ChatGPT 3.5 Turbo model selected. So let's say, for example, I have a new cat, and I want a name. So I can simply ask here, suggest a name for the cat. I would say this is rather unspecific. But let's say, if we continue clicking on submit, we're going to get different suggestions for cats. So this is essentially more or less the most common name for cats, or whatever the model thinks that are very common names for cats. Now, essentially, this is maybe not what we're looking for because our cat is actually white. So let's be more specific and say we want a name for a white cat. Now, if we click on submit, we're going to get here results that are much better suited to what we are actually looking for. Generally speaking, we can guide a model in different ways. When we're creating the prompt, we can provide clear and detailed instructions. Additionally, we can guide the model by providing examples so that the model better understands the kind of output we're looking for. Apart from this, most models also have additional settings that we can change a bit to change how, for example, creative the model is by adjusting the temperature of the model. But it's important to remember that even if you provide the same prompt to an OpenAI model, that model will rarely return the same answer. Of course, for example, when you're looking for a white cat, it's only probably a limited number of answers that you're going to get back. But essentially, it's very rarely that you will get the exact same answer based on a specific input. Technically speaking, we say that the model is non-deterministic. So the main idea of this lecture is that don't expect to get fantastic results if you don't spend a bit of time in properly designing your prompts and understanding a bit how the model reacts and how it's working. The shorter the prompt, the more generic and probably less useful the response from the model is. In general, models such as GPT 3.5 Turbo are non-deterministic. This means that the exact same prompt may generate slightly different results, and this is expected. These models work based on probabilities, like what is the most probable name for a white cat? And if we run this a few times, we'll see the most probable name for a white cat is Snowball. However, this is not very useful. We want something more creative. Creativity in terms of AI models means taking more risks and potentially providing inaccurate answers. To control this creativity, most models have a temperature setting. This temperature setting can be controlled through the API or here through the playground. To control this creativity, most models have a temperature setting, which is a value from 0 to 2. For some unknown reason, the playground has a maximum of 1, which is anyway the default value when using the API. Let's go to the API and take a look at how this temperature has an impact on the result. I've changed here a bit the chat completion endpoint, and I have here the system prompt, which is essentially saying you're a helpful assistant. Now I'm trying to get a name for a white cat. And I've set here the temperature to 0 by adding this additional property to the request body. So let's go ahead and run this and see what is coming out. So if we're taking a look here at the response, we're going to see we're getting back Snowball. Let's run this once again. And again, we're getting back Snowball. So as I said earlier, with a temperature of 0, which means almost 0 creativity, Snowball is the most probable name for a white cat. However, this is not useful in this case. I want really a creative name. I want something else from the model. So in this case, I'm going to set the temperature to 2. So this is the maximum temperature that this model allows. So let's go ahead and see what is happening then. So now we see that the model is starting to provide different values. Let's give it another try. So now we have essentially managed to get a bit different values, but in some situations it's like you're wondering like what's coming back here, right? So it's not always what we get from the model when we are having so much creativity is something that we want to use directly in an application, because then if this is a chat application or something like that, the users will be like, this is gibberish, doesn't make any sense. But I just want to briefly demonstrate like the extremes between no creativity and let's say maximum creativity, where things can really go crazy. So if we set a temperature of 0, the model will almost certainly return the same output. Essentially, it takes no chances. And this is ideal if you're looking for factual responses. However, this may also make the responses that the AI is generating look like the same every time. So there's no changes in them. They may get all the responses. For some applications, this is also not needed, because when you're interacting with a system, or let's say, for example, you're building a chatbot, when you're interacting with a human being, it's not going to say the same thing over and over again. You want to add a small variation to this. For very short prompts, changing the temperature may not always make such a difference, but it really depends a bit. Of course, if you're designing more complex prompts and you're still noticing repetitions, you may want to take a look at increasing the temperature. However, word of caution, and here's a good example for that, a high temperature may also generate incorrect answers or things that make no sense. So by increasing the temperature, the model will consider options with a lower probability. A lower probability means that things are not always correct. So in a nutshell, this is an introduction to the temperature, and it's an important setting that you should be familiar with and also start playing around with. OpenAI charges based on usage, or to be more exact, depending on the amount of data the model had to process. A model works with tokens, and the API pricing is calculated based on the tokens used. So for example, for the GPT 3.5 Turbo model, we have 0.2 cents for 1,000 tokens. This is why if you're looking at some of the requests that we have, we're looking here in the response body, we're going to find this property usage, and it's indicating us how many tokens we have used. Both the input and the output tokens matter. So the input is essentially our prompt. So in this example, our prompt has used 26 tokens. Then the response had 6 tokens, which in total makes 32 tokens. So we are going to be billed for 32 tokens. It is important to configure the models in a way that they generate only the necessary amount of information. All these models have a maximum number of tokens that they can work with, around 4,000 tokens. But typically you don't need so much. So if you're noticing that your API usage is using really a lot of tokens and generating long responses when the responses should actually be shorter, you want to look at setting the max tokens property. By default, this is the maximum that the model allows. So 4,000 tokens in case of the GPT 3.5 turbo model. So that's a lot of tokens. So if you're concerned about pricing, this is the kind of information you want to check. The good thing is that when you're using the API, you can control both the input and the output. The input totally depends on the amount of text that you put in the prompt, and the output depends on what you specified as a desired output in terms of the maximum amount of tokens that the model is allowed to use. The OpenAI API is not always guaranteed to work. Since its usage has recently skyrocketed, it is not improbable that you will experience availability issues, and this has happened in the past. I've added a link to the resources folder that takes you to this page. So if you're experiencing problems with the API, it's probably a good idea to take a look at this page and see if the API is operational. So the first thing that you should see here is the API listing, and you should see here if right now the API is available. So you'll notice here if in the last period there were any issues. But if you're looking here in the past, we're going to see that there have been some problems with this API since it has launched. So it's either very slow or you cannot reach it altogether. So generally speaking, if you cannot reach it altogether, you're not going to get a response. So Postman essentially we're just going to wait until it times out. Or the API may be responding, but is throwing you a status 500 internal server error with some error in the response body, but so not something that comes back from the model itself. So if you're experiencing something like this, it's important to be aware of this page and take a look and see if the systems are operational. Of course, on this page, you can see also other systems that are available, including the Playground or the ChatGPT API and things like that. And you can review what has happened in terms of the availability of the OpenAI systems. Let's talk in more detail about the GPT 3.5 Turbo model. This model is more opinionated on how we provide a prompt and gives a predefined structure of messages and roles associated with each message. Essentially, we have three roles. We have a system role, we have a user role, and we have an assistant role. The system role is used only once in the beginning of the conversation and is ideal for setting the context and configuring the behavior of the assistant. So typically, providing a context like you're a helpful assistant or you're translating messages from English to German is enough to get the assistant in the right mood, to put it like that. The next one is the user message, which is essentially, let's say, the typical prompt. This is where we're actually asking the AI something or we want something from the AI. Strictly speaking, providing the system is not mandatory, so we could just start with the user itself. We can write something like, I'm writing an article about the ChatGPT API, can you suggest a title? In order to get this to work, we'll also have to remove assistant from here, and we can simply submit it as it is. So this will be essentially our prompt. But of course, this is a very simple requirement that we're having here. And particularly if you're trying to build a conversational bot, having here in the system more context is very useful. However, when working with this model, it's important to understand that there are system messages, there are user messages, and there are also assistant messages. What's maybe a bit surprising is that we can also configure the assistant messages. So for example, this message that is here, we're sending here an additional message, will be part of the conversation. For example, I can ask to provide a different title, so to make a different suggestion. And of course, the conversation that we had previously is important for the AI to understand what has happened before. So we're essentially providing the entire conversation. If this sounds still a bit confusing, don't worry, because in the upcoming lectures, we're going to go through different examples and you're going to get very familiar with system, user, and assistant messages. In this lecture, we will be building a chatbot for a pizzeria. We will use messages to instruct the assistant with examples of the desired behavior. So let's get started. We're going to begin with the playground, and I'm here inside the chat mode, and the model is GPT 3.5 Turbo. We're going to start here with the system message, and let's provide the following content. So let's say we have a pizzeria, and we want to use this model to help people place an order. So we can initialize our model by something like, your name is Giuseppe and you're an assistant for a pizzeria named Pizzeria Valentino. Try to be helpful. This would be the system message. Now let's imagine that our pizzeria only has 4 types of pizza. At this point, our model is not very helpful. And if someone asks, like, what do you have on the menu? Or something like that, our bot will not be able to answer this because this knowledge is specific to our pizzeria and to our own use case. So what we're going to do next is we're going to use these messages to essentially instruct the model how to respond to such messages. So for example, we're going to provide a message and we're going to say, what kind of pizzas do you have? If we would run this as it is right now, we're going to get here essentially an answer generated by the AI. But this is not true. Our pizzeria doesn't have everything that it says here on the menu. This is when the instructing of the model starts. We're going to remove this message here and actually write our own message. You see here, this is an assistant message, but we're going to say here that we only have, and we're going to write here the kind of pizzas that we have. So let's say we have margherita, we have prosciutto e funghi, and we also have quattro formaggi. So this is everything that we have. Now we have provided additional context to our model. Now the model knows through this conversation history what kind of pizzas do we have. So if someone else asks what kind of pizzas are available, this information is already there. So for example, if we say, we start here a message and we say, hello, I would like to order a pizza. Then let's say what our model now responds. So now the model has information about the kind of pizzas we have. So we have margherita, prosciutto e funghi, and quattro formaggi. This is how we now have instructed the model by providing an already existing question. Apart from this, what's very interesting is that the model is kind of smart. So for example, if someone asks here, do you have 4 cheese pizza, which is another name for quattro formaggi, the model should be able to answer this. So here is the answer that is coming from the assistant. Okay, the main idea was just to demonstrate that we can provide also assistant messages. And with these assistant messages, we are controlling how the models should react to different messages. And we're providing information that's specific to our use case and not something that's generic and that's already in the model. Let's take a look at how we can implement this in Postman. So if we go back in Postman, we already have this OpenAI collection. So I'm going to go ahead and make a copy out of it where we will be storing all GPT 3.5 Turbo requests. So I'm going to select from the list duplicate. I'm going to go ahead and rename this in GPT 3.5 Turbo. There's only one request that we're still interested in, and this is this chat completion, which uses the chat completions endpoint. And the rest of the request is something that we're going to go ahead and delete. So I'm going to go ahead and select them all. And want to make sure that this request is still working. In this case, we have a problem with the API key because as we have copied this collection, the API key went missing. So this is something that we still need to put inside here. I'm going to grab a valid API key and save it inside here. Let's take a look if this chat completion is still working properly. We're getting back status 200 OK, so that's good. Let's also go ahead and rename it. So this will be a conversational bot. And the example is with Pizzeria Valentino. So let's jump to the body and take a look at the messages that we have here. So we have a system message, a user message, and what we also need to provide is the assistant message. So I'm going to simply delete all the information that is already available there. And just going to write here assistant. So now from the playground, I'm going to copy the system message. I'm going to provide it here in system. It's important that this is on a single line. It's going to be broken here, but you can see it's a single line and the JSON here is valid. There's nothing red being indicated. I'm going to copy one of the user messages. I'm also going to copy one of the predefined responses that we're providing here. So this is something that we already have with every request as a minimum for our bot. Now the next part is the one where we now have the user input. And for this user input, we're actually expecting something from the model. So this is essentially the interface. If we were to build something, this is where we would put the input that is coming from our end user. So the end user will start here writing something like we had here. So I would like to order a pizza, right? So this is something that the user would then write. And we're not providing a response. So the training ends here. So this is where the AI starts working. So let's see the AI in action and take a look at how this is being responded to. So it says here, hello, great. May I have your order, please? So there's a different message this time. And of course, if we want to continue this conversation in the next request that we're sending to the API, we would need also to provide this assistant message here. So that the assistant, if there was an important message in between, knows what they said previously. So this is something that's very important to remember. When we're building these conversations, every upcoming message must have the entire history. Otherwise, the model has no idea what they said previously. But anyway, for this use case, it's something that we don't need anymore. The main idea was just understanding that we can provide the system message to set the context, and then we can instruct the model with examples, and we have provided here one example, one question and one example, how we would like ideally the model to answer that particular question. Let's imagine that we want to use this model to provide a summary of larger text. I'm here inside the OpenAI Playground. I have the mode chat selected, and the model is GPT 3.5 Turbo. So here as a system message, I can write something like you're a helpful assistant that provides a summary of every text entered by the user. And this can be already our system message. I'm going to go here to a Wikipedia article. I'm going to copy a block of text. There are a lot of facts inside here, so it's not going to be easy for the AI to provide a summary. But for this example, it will be enough. So I'm going to paste all this text here as a user message. And I'm going to simply go ahead and run submit. So what we'll see here as an assistant message is what comes back. So this is short summary of everything that is in this larger text. So this is how you can provide a summary, but this is not actually the thing that I wanted to show you. What I wanted to show you is how to make a request from Postman that has all this text. So I'm going to go ahead and copy this text here. So let's go back into Postman, and we can just simply duplicate the previous request that we have, and we can rename it into summary. So this is what we're trying to do. Let's take a look here inside the body. There are a few messages that we don't need, so we're going to remove those. So we're going to have here a system message, and we're also going to have here a user message. So let's start with the system message. You can simply copy this from the OpenAI Playground and paste it here. And additionally, we can also take this longer message that we have here and paste it here inside the content. So what we'll see as soon as we do this, everything will turn into red. So nothing will work anymore. And this is not valid JSON. So if we're trying to send this, we're going to get back an error telling us that the JSON body could not be parsed. So there's definitely something wrong with our request. So I'm going to undo this change that we have here. So in order to actually send this multi-line text, we need to do a few things. In the resources folder, I've included a script that we'll be using here. So if we now go to the pre-request script and paste the script that you will also find attached as a resource to this lecture, you should see something like this. Of course, I'm going to provide some improvements over time to these replacements that happen here. But essentially, there are a few things that we need to replace. We need to replace new lines. We need to replace some special characters to actually make our text a valid JSON. So let's go ahead, copy this text that we have here. And I want you to notice here that these are backticks here. This allows us to define a JavaScript variable, which is called user message. It allows us to write it here on multiple lines. So this is where our user message will be. And this is just necessary in order to use this in Postman. It's not so easy to work with so much text all of a sudden, but with these AI models, quite often we are working with a lot of text that we need to process before we actually send to the AI. So this is just a small hack that we need to do. But essentially, we're writing our text inside this JavaScript variable. We are doing some processing here, and then we are storing it in a Postman variable called user message. So if we go here to the body, I'm going to write here 2 braces. I'm going to close them also at the end. So this is the syntax for a variable in Postman. And what Postman will do, we will take this variable that has been created here in the pre-request script, and it will use it as the request has been sent. So let's go ahead and send this request once again. And what we're getting back is now the summary, which is available here. And you will see here the role assistant. So this is coming back from the AI. So this is how, with a bit of tricks, we can work with Postman and provide multi-line text. It's definitely not as easy as working here with the playground. But if we're trying to integrate the API in our own applications, it's important to understand how the API works. And sometimes we need to deal with these kind of things. So one last thing, I'm going to rename this in multi-line message so that we know that this is the example where we have multi-lines, where we have the script, because this may be useful in the near future. Let's imagine that we want to use this model to provide a summary of larger text. I'm here inside the OpenAI Playground. I have the mode chat selected, and the model is GPT 3.5 Turbo. So here as a system message, I can write something like, "You're a helpful assistant that provides a summary of every text entered by the user." And this can be already our system message. I'm going to go here to a Wikipedia article. I'm going to copy a block of text. There are a lot of facts inside here, so it's not going to be easy for the AI to provide a summary. But for this example, it will be enough. So I'm going to paste all this text here as a user message. And I'm going to simply go ahead and run submit. So what we'll see here as an assistant message is what comes back. So this is a short summary of everything that is in this larger text. So this is how you can provide a summary, but this is not actually the thing that I wanted to show you. What I wanted to show you is how to make a request from Postman that has all this text. So I'm going to go ahead and copy this text here. So let's go back into Postman, and we can just simply duplicate the previous request that we have, and we can rename it into summary. So this is what we're trying to do. Let's take a look here inside the body. There are a few messages that we don't need, so we're going to remove those. So we're going to have here a system message. And we're also going to have here a user message. So let's start with the system message. You can simply copy this from the OpenAI Playground and paste it here. And additionally, we can also take this longer message that we have here and paste it here inside the content. So what we'll see as soon as we do this, everything will turn into red. So nothing will work anymore. And this is not valid JSON. So if we're trying to send this, we're going to get back an error telling us that the JSON body could not be parsed. So there's definitely something wrong with our request. So I'm going to undo this change that we have here. So in order to actually send this multi-line text, we need to do a few things. In the resources folder, I've included a script that we'll be using here. So if we now go to the pre-request script and paste the script that you will also find attached as a resource to this lecture, you should see something like this. Of course, I'm going to provide some improvements over time to these replacements that happen here. But essentially, there are a few things that we need to replace. We need to replace new lines. We need to replace some special characters to actually make our text a valid JSON. So let's go ahead, copy this text that we have here. And I want you to notice here that these are backticks here. This allows us to define a JavaScript variable, which is called user message. It allows us to write it here on multiple lines. So this is where our user message will be. And this is just necessary in order to use this in Postman. It's not so easy to work with so much text all of a sudden, but with these AI models, quite often we are working with a lot of text that we need to process before we actually send to the AI. So this is just a small hack that we need to do. But essentially, we're writing our text inside this JavaScript variable. we are doing some processing here, and then we are storing it in a Postman variable called user message. So if we go here to the body, I'm going to write here 2 braces. I'm going to close them also at the end. So this is the syntax for a variable in Postman. And what Postman will do, we will take this variable that has been created here in the pre-request script, and it will use it as the request has been sent. So let's go ahead and send this request once again. And what we're getting back is now the summary, which is available here. And you will see here the role assistant. So this is coming back from the AI. So this is how, with a bit of tricks, we can work with Postman and provide multi-line text. It's definitely not as easy as working here with the playground, but if we're trying to integrate the API in our own applications, it's important to understand how the API works, and sometimes we need to deal with these kind of things. So one last thing, I'm going to rename this in multi-line message so that we know that this is the example where we have multi-lines, where we have the script, because this may be useful in the near future. Have you ever wondered why the text inside ChatGPT is displayed in chunks and not all at once? Initially, I thought this is just a visual effect to reduce the number of requests the user can submit or something like that. But it's not that, or not only that. Some responses take some time to get, even 10 seconds. Now, we don't want our users to wait so long and not get any visual feedback. In our example so far, this was not the case. Sometimes when we're using the chat completions API, we have to wait a lot. So in that time, we cannot display anything in our apps, which is less than ideal. However, if we're looking at the API documentation, and we are here in the API reference under chat for the chat completions, there is one interesting option that we need to consider, and this option is the stream option. So let me show you what this stream option does, which by default is set to false. I'm going to jump back to Postman and I'm going to duplicate the previous request. Let's rename this streaming output. We can leave the body and the pre-request script as they are, but the change that we want to make is actually here. So under model, I'm going to add a new property which is called stream. And as I mentioned previously, by default, stream is false, but let's set it to true. So I'm going to go ahead and submit this. And what we're going to see here is something very weird. First of all, look here at the time. This is constantly changing. Look at the size. This is also changing. Essentially, what is happening here is that we are getting this response in chunks, in smaller chunks. So these are like individual messages, and it's quite a lot of them because there's a lot of text. But it starts here. It says connected to this completions endpoint, and it ends somewhere here at the top when the last message comes, and then the connection is closed. So this is essentially the streaming of this message. We are getting everything as it happens. So right from the beginning, we're already getting some data. We are getting a token by a token. So let's look here somewhere in the middle. We click on one of these. Let me make this a bit larger. We're going to see here, we're getting essentially a delta, getting a piece of information, intelligence. And then if we're looking at the next message, since. So it's one token at a time. And if we use this streaming property, then we can also get this content one at a time. Look, for example, at the difference between using this option, so we are getting some messages instantly, to setting here stream to false. The exact same input, we're waiting and waiting and waiting and still waiting. And finally, after 11 seconds, we have the entire response. Let's change this back to true. These are called server-sent events. Obviously, seeing this in Postman is not very practical because you have to go through each and every message. But if you want to implement this in your own application and replicate the way ChatGPT is displaying text, then this stream property is definitely something you should consider. One way to control the model is by limiting the length of the output by specifying a maximum number of tokens in the response. If you look at the API documentation, we are here under chat and we're doing a chat completion. We'll be able to find this setting here, which is called max tokens. Max tokens says the following: the maximum number of tokens allowed for the generated answer. By default, the number of tokens the model can return will be 4096 minus prompt tokens. So by default, the maximum tokens used in the response is also the maximum that the model can generate. Based on our use case, we should have a general idea of how long the response needs to be. We rarely need the maximum the model can produce. Now I understand if this sounds a bit confusing, so I think it's better to take a look at some examples. I'm gonna jump back to Postman and I'm gonna copy this request summary. Let's go ahead and drag it down here. I'm gonna rename it in max tokens. There's gonna still be a summary, but we're gonna use the property max tokens. So just as a short recap, we have here a large text and our prompt is currently configured through a system message, and we're saying we are a helpful assistant that provides a summary of every text entered by the user. And this is where we're providing the text. Let's go ahead and run this. What we'll see here is what comes back. This is a summary that has been generated by the assistant. And we're also getting here information about how many tokens have been used. So you want to see our prompt has 424 tokens. Completion tokens were 165. And in total, we have used 591 tokens. So if you already have an idea of the kind of information that we're dealing with, so in this case, the maximum of 4096 tokens that this model can produce doesn't make any sense. This is not something that we will need. But let's see exactly how this influences what we're getting here. So we know that the completion has currently about 167 tokens. We can even run it once again. Now we're getting 224 tokens. Of course, this always varies. But let's go ahead and add here a property. And the name of the property is max_tokens. And let's say we're setting here max tokens to 100. So let's say we want an even shorter answer. So if we're looking here, completion tokens, 100. Our prompt hasn't changed, it's the same prompt. And in total, we have used now, of course, fewer tokens. But let's take a look at the response that we have here. What we'll see here is still some text, but at one point in time, this text ends. So what you need to understand about max length is that setting it will really make a hard cut. While setting a limit is probably a good idea, in practice you don't want to hit this limit too often. A common misconception is thinking that if you set a low max length, this will cause the model to make the response even shorter. Max length doesn't control the real length of the output. So this is not the use case for this. Setting this limit is useful to control the length of the model and to ensure it is not giving extremely long responses. This is also a way to control cost in case things don't work as expected. But if you need shorter responses, one way to control this is by designing a better prompt, where you can even explicitly mention how many words the response should contain. Now, it doesn't mean that the model will always take this in consideration, but that's where you want to be. So let's say, for example, we're making some changes here. So we're going to set here the max tokens to 1000. So just to make sure that we're not hitting any limits. And apart from this, we should also adapt a bit our prompt. So let's say, for example, we want the summary to contain 100 words. So we can amend our initial instructions that we have in the system and say here something like the summary needs to contain a maximum of 100 words. 100 words is not the same as 100 tokens, but that's a round number. So let's see how the model interacts with this. So as you can see here, now we have 131 completion tokens, and we haven't hit that limit. So as you can see, we have managed to reduce the number of completion tokens used without hitting a limit. So when you're setting this limit, it should also contain a buffer. So if I know that I've instructed my prompt to generate responses that are about 100 words, 100 words is about like 125 tokens, then probably setting here a value of max tokens of 300 would be a good value for this use case. Setting it to low will cause the text to be abruptly interrupted, so this is also something that we don't want. There's one more important aspect you need to remember about max tokens. What you need to understand is that this is just a theoretical limit you can achieve. If you are sending a prompt with 3000 tokens and ask, for example, the model to rephrase it, the total token usage will be about 6000 tokens, which is above the maximum allowed. So just to recap, the token usage is counted as follows: the tokens in the prompt plus the tokens from the response equals the total number of tokens used. This value needs to be below the maximum number the model can process. So even if we set a maximum value of 4096, the response will contain so many tokens only if our input has no tokens at all, which is unrealistic. If you need a quick refresher in terms of tokens, all you have to do is open up this website, the tokenizer from OpenAI, link in the resources folder, and you can paste here your text and understand its size in tokens and better understand how the model operates in terms of tokens. One last thing, we mentioned here max tokens, but if you're looking here in the API documentation, you will also notice that there is no min tokens. Essentially, it's important to mention that currently you cannot set a minimum number of tokens that the model will generate. So you can set a maximum number of tokens, but you cannot say the response must be at least 100 tokens. All right, so in a nutshell, this is the usage of max tokens. Remember to set a value that's realistic for you and also add a bit of a buffer, but this is not something that you use to actually control the total length of the response that the model is generating. There are situations when we need to tell the model to stop generating text once we have reached a desired point. We can do that with a stop sequence. If we look inside the API documentation, one of the options available here is the property stop. So this property will allow us to configure essentially a token or multiple tokens, and when the model will detect that token in the response, it will stop. Let me show you an example so that you better understand what I mean. We're going to jump into Postman, and let's take the first request that we have here. I'm going to go ahead and duplicate it. And let's drag it all the way down. And I'm going to go ahead and rename it into stop sequences. So we're going to go inside the body. And let's configure this a bit. So there are a few messages here that we don't need. I'm going to go ahead and remove this. And the system, we're going to add something more generic like you are a helpful assistant. All right. So let's say, for example, we want to ask the model to generate 10 titles for a travel book about Mexico. I'm going to go ahead and send this. And if we're looking here in the response, what we're going to see here is that we're getting a list of book titles, which is useful if we're writing a travel book about Mexico. Now, let's say, for example, the list that the model is generating is too long for what we need. Now, of course, we have said that we want 10 titles and the model has generated 10 titles. But let's just imagine that we have just said suggest some titles and we actually only need 3 titles, right? Now, in this case, we want to stop as soon as we're done with the 3rd title. So if we're looking here at the existing response, we're going to see here a character. And this is this /n, and then it starts with 4 dot. So essentially, we want to, as soon as we are reaching here 4 dot, we want to stop. So essentially, before we reach 4 dot, we want to stop because it will include only 3 suggestions of titles. So once we have figured out what is the character or the token inside the response that we want to stop at, all we have to do is copy this. And I'm going to go ahead and under the model, let's add, for example, stop as a new property. And we're going to say, okay, when you're reaching this token here, 4 dot, which actually are 2 tokens, you should stop the generation. And what we expect is that 4 dot will no longer be part of the content that we're getting here. So let's see how this goes. So remember, we are still saying suggest 10 titles. And if you're looking here at the response, we're going to find the first title, we're going to find the second one, the third one, and after that it stops. And it stops because we have told the model, when you're encountering this particular token or tokens, you have to stop. Just to make sure you understand. Let's say, for example, we're asking the model to stop when the word Mexico is encountered, which means we're not going to have the word Mexico at all. Of course, this will absolutely break the response that we're getting back because it's not going to be able to generate anything useful. But this is it. It's stopping as soon as this is encountered. And actually, I would have expected that this is not part of it at all. Let's try it again. Discovering Mexico. So this is how we have now configured this stop character here. Let's add, for example, a space before it. And now we're going to see here, Mexico is now missing completely, right? Because it has matched this also with a space. So now we are actually not getting it at all. Exploring, so Mexico will not appear. Anyway, I just wanted to demonstrate how you can configure this. Of course, with a word like Mexico, it doesn't make a lot of sense, but the idea is to instruct the model a point where it needs to stop. Let me show you, for example, something more useful. For example, let's say that we are having a text that has 2 paragraphs, and we actually only need 1 paragraph. So again, I'm going to create a prompt in a way that the model will generate 2 paragraphs. So I'm going to say here, explain how the USA was founded in 2 paragraphs, right? So I'm explicitly requesting 2 paragraphs. I don't have any stop characters, so let's go ahead and run this. And if you're looking here, what do we have in the response? Let's see, this is the part where we have the paragraphs ending. So /n, these are essentially 2 new lines that we're getting here. So we want to stop as soon as we are encountering a new line, which shows that this is a new paragraph, we want to stop. So let's say this is our criteria. We only want 1 paragraph from the response. We never need 2 paragraphs. And for some reason, the model is generating us 2 paragraphs. So let's go ahead and configure our stop tokens. So we're going to write /n, /n. Let's hit again the send button. And if we're taking a look here at the response, we're going to see here that our text is ending here. So after these characters have been encountered by the model, the generation stops, and we're no longer getting 2 paragraphs. So these are like some of the use cases that you may want to consider if the output that is coming back doesn't really contain what you expected. So this is essentially the use of these characters. Of course, you can also specify up to 4 stop characters. So there may be situations where we need multiple characters. Currently, we only have 1, and this is represented here as a string. However, if you need to specify 4 of them, you need to put them in an array. So it's going to be a square bracket in the beginning, square bracket at the end. Of course, if you need multiple, you'll just have to put them between quotes, another option, ABC, and so on. You got the idea. So this is how we can specify up to 4. You can go ahead and try and see if this is still working. Let's remove the spaces there. Now it's working properly. I admit these examples that I've presented here are fabricated to facilitate this demonstration. However, this can also be a useful thing to know if you notice that the model is not performing as expected. So of course, this is a way to ensure that the response doesn't derail. And for this reason, you can specify these stop sequences, which are then taken into consideration when the response is generated.